Today we're going to be learning about the real number system, and then later in the lesson I'm also going to quickly go through the properties of numbers and factors and multiples with you as well. But first let's have a look at real numbers. Real numbers have the symbol R, and they are all the numbers that can be represented on a number line. So if you look at the number line over here, any number that can go anywhere on this number line is part of what we call the real number system. We've already learned about whole numbers, which are part of the real number system. They have got the symbol N0 or W, and they are all the numbers that we use when we count objects starting at 0. So if you look at the number line over here, then the whole numbers, the first one is going to be 0, and then we've got 1, 2, 3, 4, 5, 6, and so on, going up to positive infinity. All the numbers that we use when we are counting objects and including 0, those are our whole numbers. Then we've also got natural numbers, which have got the symbol N. Natural numbers are the same as the whole numbers, except that they do not include 0, they exclude 0. So it's just 1 up to positive infinity, 1, 2, 3, 4, 5, 6 up to positive infinity. And just like whole numbers, they are also numbers that we use when we are counting objects. Okay. Then we've also got integers that we've learned about before. They have got the symbol Z, and they also are the same as the whole numbers. So we also have 0, 1, 2, 3, 4, 5, 6 up to positive infinity, but they also include the negative numbers, the numbers that are below 0. So that's going to be -1, -2, -3, -4, -5, -6, and so on down to negative infinity. So those are our integers. So all the numbers we've looked at so far are numbers that are not fractions. They can be written as fractions, but then the denominators will be 1. Okay, but they don't have to be written as fractions. They can just be written as plain numbers like this. Those are our integers. Our whole numbers are natural numbers. But if you look at the number line, there are an infinite number of numbers in between the ones that we've got highlighted over here. If you look just in between 0 and 1, you've got a half, you've got a quarter, you've got a third, you've got a sixth, you've got a tenth. You've got an infinite number of fractions in between there. So we also need a way of classifying all of those numbers that are also on the number line that we haven't classified yet. So we're going to now look at rational numbers, which have got the symbol Q. Okay, so rational numbers are all the numbers that can be written in the form A over B, where A and B are integers. So they can be written as a common fraction. And B cannot be equal to 0, because if B is 0, it means you're dividing by 0, and then it's going to be undefined. Okay, you cannot divide by 0 ever. So rational numbers are numbers that can be written in the form A over B, where A and B are both integers and B is not equal to 0. Okay, then we also have irrational numbers. Irrational numbers are numbers that cannot be written in the form A over B. They can't be written as a common fraction. They are non-terminating decimal fractions, which means that they have an infinite number of decimal places, and they're also non-repeating, which means that they don't have a pattern. So that means that they are going to continue going on forever and ever and ever and ever, their decimal places. And also there's not going to be any kind of pattern that's going to form as you look at the numbers in the decimal places. So there are decimal fractions that are non-terminating and non-repeating, and those are our irrational numbers. So now if we look at our number line, we have got the numbers that we've looked at were all the numbers 1 to 6. Those are our natural numbers. Remember, they are numbers that we use when we're counting objects but not including 0. Then if we add in 0, then we have our whole numbers. So the whole numbers are the same as the natural numbers, but it also includes 0. So natural numbers are part of the whole numbers. Then if we take our negative numbers as well, then we get our integers. So our natural numbers and our whole numbers are part of the integers. Then we also have all the other numbers in between all of the integers that we haven't highlighted yet on the number line. Those are our rational and irrational numbers. But please be aware that the integers, the natural numbers, the whole numbers, those are also rational numbers because they can be written in the form A over B. It's just that B, the denominator, will always be 1 when you're working with rational numbers, or when you're working with integers, natural numbers, and whole numbers. Okay, so now we're going to go on to an example where we're going to just quickly learn about classifying numbers in the different categories. So if we've got our real numbers, first of all, real numbers is divided up into two groups. We've got rational numbers and we've got irrational numbers. If you take a number in the real number system, it is either going to be rational or it is going to be irrational. There's nothing else that it can be. But if it is rational, it could be classified in other ways as well, to be more specific. So within rational numbers, we've also got integers. Okay, so we've got, remember, integers are also rational numbers, but not all rationals are, well, not all rational numbers are going to be integers, but all integers will be rational numbers. That's why the integers is inside the rational numbers block. Then within integers, we've also got our whole numbers. Again, whole numbers are also integers. And then within the whole numbers, we've also got our natural numbers, which are also whole numbers. So natural numbers are part of the whole numbers. They are also part of the integers. They're part of the rational numbers, which is part of the real number system. Whole numbers are part of the integers. They're part of rational numbers, which are part of the real number system. Integers are part of rational numbers, and which are part of the real number system. Okay, so now let's have a look at an example where we're going to look at some numbers and see where they fit. So the first one over here I've got is a half. Now a half has already been written in the form a over b, so it is a rational number. It can't be simplified and give you a whole number or an integer, so it is a rational number. The next one is negative 30. Now negative 30 is not a fraction, so it's going to either be a natural number, a whole number, or an integer. But because it's negative, it has to be an integer, because these ones only deal with positive numbers. So negative 30 is going to be an integer. Then I've got the number 1, which is a positive whole number, so it's going to be a natural number. The number 5 is also a natural number. Negative 2 over 7 is a rational number because it has been written in the form a over b, and it can't be simplified to give you a whole number or an integer. Okay, then the number 0, just be aware that the number 0 is going to be in the whole numbers block over here. It is an integer. Integers also include 0, but it's not a natural number, because remember, the natural numbers are the same as the whole numbers excluding 0. So 0 is the only number that will be in this block over here, because every other whole number is also going to be a natural number. The only whole number that's not a natural number is 0. Then we've got 317, which is a natural number. Negative 87 is going to be an integer because it is not a fraction and it is negative. Negative 3029 also is going to be an integer. 4/9 is going to be a rational number because it is in the form a over b. Then I've got pi. Pi is an example of an irrational number. If you take your calculator and you type in pi and you type equals, you're going to end up with your calculator giving you a decimal fraction, which obviously on the calculator is going to be shortened. But if you were to take the actual number pi, it keeps on going forever and ever and ever and ever. It's never going to actually end. There's an infinite number of decimal places. You may have been taught in the past that you can use 3.14 or 3.142 or 22 over 7 for pi. But please be aware that that is not an accurate version of the number pi. So you actually need to now start using the pi button on your calculator instead of using those versions of pi. Okay, so pi is an example of an irrational number. Then the next one, negative 62, is going to be an integer because it's not a fraction and it is negative. Same thing with negative 725, and the same thing with negative 2. Now this one over here is an interesting one. We've got negative square root of 5. Now the square root of 5, what you need to know is any number that is not a perfect square, if you try and take the square root of it, you will get an irrational number. It doesn't matter if it's positive or negative. So this negative over here the negative over here doesn't make any difference. Because I've got the square root of 5 and 5 is not a perfect square, this is an irrational number. Okay, then the next one, negative 429 over 56. This is going to be a rational number. And then negative 18 over 5 is also a rational number. And then over here, I've got another one where I've got the cube root of 6. Now, the cube root of 6 is also going to be irrational because 6 is not a perfect cube. So if you try and take the cube root of a number that's not a perfect cube, it's also going to give you an irrational number. Same as if you try and take a square root of a number that's not a perfect square, it's going to give you an irrational number. So this one over here is also going to be irrational. And then I've got the square root of 43. the same thing. 43 is not a perfect square, so that is going to be irrational. And then I've got 2,649, that is going to be a natural number because it is not a fraction and it is positive. And then 29 is also a natural number because it's also not a fraction and it is positive. Okay. Now you're going to do an activity where you are going to classify numbers yourself as real, rational, integers, whole numbers, natural numbers, and or irrational numbers. Okay, so you need to determine for each of these how they can be classified. Now, they may be able to be classified in more than one way. Okay. You're going to have to, for some of them, simplify. Like in this example that's been done for you, if you look at it, 12 over 3 can be simplified to 4. Okay, 12 divided by 3 is 4. So this is negative 4. And that's why it has been checked over here for real numbers, because it is a real number. It's also a rational number because it can be written in the form a over b, but it is also an integer. Okay, now in the examples we were doing over here, none of the numbers we had in the integers were in the form of fractions, but that's because they were all in their simplest form. Okay, now we're looking at ones that are not necessarily in their simplest form. You have to simplify them first and then classify it. So if this one over here, if you simplify it, you get negative 4, and negative 4 is an integer. So that's why that one is ticked over here. It is not a whole number because it is negative. It's not a natural number because it is negative. And it is not an irrational number because it can be written in the form a over b. Okay, so you're going to now do the same thing for each of these over here. Just be careful with some of them. Remember about rules that you have learned in the past. Okay, so I'm going to give you 3 minutes to work on this classification. Okay, so let's go through each of those. So the first one was 6. So first of all, you have to know that is a real number, okay? Then it is also a rational number because it can be written in the form a over b. If you write in the form a over b, it will be 6 over 1. It's also an integer because it's not a fraction, or it has a denominator of 1. It's also a whole number because it is positive, and a natural number, but it is not an irrational number. So the number 6, you should have all of them ticked except for irrational number. The next one, negative 2 over 11, is a real number, and it is also a rational number, but you can't simplify that and get an integer or a whole number or a natural number. So that is as far as it goes, and it's not an irrational number because it is and can be written in the form a over b. Next one, the square root of negative 36. Now this one you had to be very careful, okay, because you cannot take the square root of a negative number in the real number system. When you take the square root of a negative number, it actually gives you a non-real number or an imaginary number. So none of these are going to be ticked because it's not a real number. Even though 36 is a perfect square, because it's negative, it is non-real or imaginary. Next one, we've got negative square root of 50. Now 50 is not a perfect square, which means that this is not going to be an integer or a whole number or anything like that. It is going to be a real number. It is part of the real number system because you can take the square root of a positive number, but it is irrational because it's not a perfect square that you've got over there. Then the next one, the square root of 0.25. Now 0.25 is not one of your traditional perfect squares, but you can take the square root of 0.25 and get something that is going to work, because remember 25 is a perfect square, okay? So the square root of 0.25 is going to be 0.5. So that is a real number, and it is a rational number. It is not an irrational number. Okay, because 0.5 can be written as 1 over 2, which is a rational number. It's in the form a over b. Next one, 0 over 4. Now 0 over 4 can be simplified to give you 0. You're taking 0, dividing by 4 gives you 0. That is a real number. It is also a rational number because it can be written in the form a over b. And it is also an integer, and it is a whole number. It is not a natural number because the natural numbers are the whole numbers excluding 0. So this over here, which simplifies to 0, is not going to be a natural number, and it's not an irrational number. The next one, we've got negative the square root of 100. Now 100 is a perfect square, and if you square root, you get 10. So that's going to be negative 10. So the number we're looking at over here is negative 10. So negative 10 is a real number. It is a rational number. It is an integer. It is not a whole number and is not a natural number because it is negative, and it's not an irrational number because it can be written in the form a over b. And then the last one over here, 5 over 0, this one is undefined because it is dividing by 0. You cannot divide by 0, so that means that this is not going to be part of the real number system. It is undefined. Okay, so now let's have a look at the properties of numbers. The first property we're going to look at is the commutative property. Okay, the commutative property says that when you are adding or multiplying numbers, the order of the numbers can be changed without affecting the answer. So if you take over here, 2 plus 3 is going to give you 5. If you switch around the 2 and the 3, it's still going to give you 5. That is the commutative property. When you are adding two numbers or more than two numbers, it doesn't matter what order the numbers are in, you will still get the same result. So we can say that a plus b is the same as b plus a. It doesn't matter which order they're in. And the same thing applies for multiplication. A plus b or a times b is the same as b times a. Okay, so that is the commutative property. When you're adding or multiplying numbers, it doesn't matter which order the numbers are in. They will still give you the same result. Okay, next one is the associative property. The associative property says that when you're adding or multiplying numbers, the numbers can be grouped in different ways without affecting the answer. Okay, so if you look at an example over here, we've got 2 and 3 together, so 2 plus 3 in brackets, plus 4, all gives you 9. Okay, now if we group this differently, if I take the 3 and I put it over here with the 4, then I have 2 plus, and then the 3 and the 4 grouped together, it's still going to give me the same result of 9. Okay, so it doesn't matter how the numbers are grouped when we're adding or multiplying, we will still get the same result. So a plus b in brackets plus c is the same as a plus b plus c in brackets, and the same thing applies for multiplication. I can also group them in different ways and I will still get the same result. So that is the associative property. The next one is the distributive property. The distributive property says that when you are multiplying the sum or difference of two numbers by a third number, it is the same as multiplying each of the two numbers by the third number separately and then adding the answers. Okay, so let's have a look at this over here. So if I've got 5 groups of 4 plus 3, okay, so that's what this is showing you over here, 5 times 4 plus 3. So I've got 5 groups of 4 plus 3. That gives me 35. Okay, it's just going to be the exact same thing as if I take 5 groups of 4 and 5 groups of 3 and I add it all together. Okay, it's still going to give me 35. So over here I can say that a times b plus c is the same as a times b plus a times c. Okay, it also works with subtraction. So if you have in the brackets a minus, it's also going to work. So if I have a times b minus c, then it's the same as a times b minus a times c. So I've got a times b and a times negative c giving me that minus a times c over there. Okay, so that is the distributive property. Then I've got the additive inverse property. The additive inverse property says that the sum of any number and its additive inverse, which is obtained by changing the number's sign, is 0. Okay, so if we look over here, if I've got a and I add the additive inverse, which is the negative or the opposite version of a. So if I've got a, then I change the sign and I get negative a. If I had negative 2 and I change the sign, it would be positive 2. If I add those together, I will always get 0. So if you are adding two opposite numbers, one is positive, one is negative, you will always end up with 0. That is the additive inverse property. Then the multiplicative inverse property is that if you take the product of any number and its multiplicative inverse, which is obtained by inverting the number written as a fraction, you will get 1. Okay? So if I have the number a and I multiply it by its inverse, where I take this a, write it as a fraction, which would be a over 1, and I invert it, it's going to be 1 over a. If I multiply those together, I will always get 1. Okay, same thing happens if you already have a number that's written as a fraction. So a over b multiplied by its inverse, which would be b over a because I'm flipping it over, okay, that will give me 1. So anytime you multiply something by its inverse, its multiplicative inverse, it will always give you 1. Now let's have a look at factors and multiples. You've already learned about factors. Factors are numbers that divide evenly into a given number with no remainder. So example, if you have the number 6, the factors of 6 would be 1 and 6 and 2 and 3. Those are our factor pairs for the number 6. They divide evenly into the number 6 without any remainders. Now let's have a look at the highest common factor, or the HCF. The highest common factor for a set of numbers is the highest factor that is the same for each number in the set. Okay, and then the lowest common multiple, which is the LCM. The lowest common multiple for a set of numbers is the lowest multiple that is the same for each number in the set. Now, you have learned how to find the highest common factor and the lowest common multiple by listing the factors and listing the multiples and looking at the factor to see which is the highest and looking at the multiples to see which is the lowest. But you also should have learned how to use prime factorization to find the highest common factor and the lowest common multiple. So I'm just going to quickly go through that with you to remind you about how to do that. Okay, so in this example, we are going to find the highest common factor and the lowest common multiple for the numbers 120 and 180. Okay, so now I'm going to go and do this using the ladder method in order to write these numbers as the product of their prime factors. So hopefully you've learned how to do the ladder method before, but this is just, I'm just going to remind you how to do it. So we've got 120, and what we're going to do is we're going to divide 120 by prime numbers until we can't anymore, starting with the smallest prime number, which is the number 2. Now remember, prime numbers are numbers that have exactly 2 factors. Okay, so 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, 11 is a prime number, and so on. Okay, So the first prime number is the number 2. Now I can divide by 2 because this is an even number. So 120 divided by 2 is 60. I can still divide by 2 because it is still an even number, so I'm going to divide by 2 again. 60 divided by 2 is 30. Now that is still an even number, so I'm going to divide by 2 again, and that gives me 15. Now I can't divide by 2 again because 15 is not an even number. So now I'm going to go on to the next prime number. The next prime number is 3. Now 3 does go into 15, so I'm going to divide that by 3, and that gives me 5. Now obviously 5 is not a multiple of 3, so I can't divide by 3 again. The next prime number though is 5, so I'm going to divide by 5, and that gives me 1. So I keep going until I get to 1, and then I'm done. So that is the ladder for 120. Now I'm going to do the exact same thing for 180. So I'm going to take 180, and I'm going to work out what the ladder looks like for 180. So I'm going to say, first of all, 180 is an even number, so I'm going to divide by 2. So that gives me 90 if I divide by 2. Then I still have an even number, and that means I can divide by 2 again. That gives me 45. Now 45 is not an even number, so that means I can't divide by 2, so I'm going to go on to my next prime number, which is 3. So to work out quickly if I can divide by 3, I can just add the digits in the number over here. 4 plus 5 is 9. 9 is a multiple of 3, that means that I can divide by 3. So 3 goes in over here into 45 15 times. Now I'm going to divide by 3 again because 15 is still a multiple of 3, and that gives me 5. Now I can't divide by 3 again, but now I can divide by 5, and that gives me 1. So that is what the ladder looks like for 180 and for 120. Now once I've got my ladders, I need to take each of those numbers and write them as products of their prime factors. So what I'm going to do is I'm going to write, there are actually 2 ways of doing this. I'm going to show you both ways. You can choose which method you prefer. So the first method I'm going to do where I just write the factors out multiplied with each other. So I'm going to say 120 is equal to, and I'm going to write them so that the factors that are the same are underneath each other. So I've got 120 is equal to 2 times 2 times 2. 180 is equal to, it's also got a 2 times 2, so those are going to go underneath those. Then over here I've got a times 3, and over here I've got 3 and 3, so I'm going to have times 3 and times another 3, and then I've got a 5 and a 5, so I've got times 5 and I've got times 5. Okay. So once I've got those written underneath each other like that, now I'm going to go and find my highest common factor. The highest common factor I'm going to work out by looking at these and seeing what is the same. And I'm only going to multiply each of the factors that is the same in both. So over here I've got that is the same, and that is the same. This isn't because there's no 2 over there. This is the same. That isn't because there's no 3 over there, and this is the same. That's why it's useful to write them underneath each other, because then you can easily see what is the same. Okay, so now I'm going to multiply each of those factors that is the same for the 2 numbers together, but I only write them down once each. So I'm going to write down 1, 2 for that over there, times a 2 for that over there, times, I'm not going to do this one because it wasn't common. Then I'm going to multiply by this 3 over here, and I'm not going to do this 3 because it's not common. I'm going to multiply by this 5 over here, and then I can work that out. Okay, so that gives me 2 times 2 times 3 times 5 is 2 times 2 is 4 times 3 is 12 times 5 is 60. So my highest common factor for 120, 180 is 60. Now we're going to find the lowest common multiple. So to find the lowest common multiple, we're going to also take the numbers that were written that are common and write them down once, but we're also going to write down the numbers that aren't common. So I'm going to say 2 over there for that pair, times 2 for that pair. Then I'm also going to multiply by this 2 that I didn't multiply by when I was doing the highest common factor. So I'm going to multiply by 2 times this common 3 and times the 3 that isn't common, and then multiply by the 5. Okay, and when we work that out, I get 2 times 2 times 2 times 3 times 3 times 5, and that gives me 360. So my lowest common multiple is 360. Okay, so this is the first method. Now, like I said, there is another method that you can use. Okay, now you may prefer this method now that you've learned about exponents last year, you should be able to do the second method, and you may prefer this method. So the second method is to write these in exponential form. So I've got 120 is the same as 2 times 2 times 2 is 2 cubed, 2 to the power of 3 times 3 times 5. You can still write normal time signs if you want, or you can just write dots. Okay. Then 180 I can write as 2 squared times 3 squared times 5. Okay, so that is how I can write it in exponential form. Now, when you're finding the highest common factor and the lowest common multiple, when it's written in exponential form, what you're going to do for the highest common factor is you are going to look for each of the bases that is the same, and you're going to use the lowest exponent that is there. So I'm going to first look at the 2's, and I'm going to use the lowest exponent. So it's got a 2 to the power of 3 and a 2 to the power of 2. The lowest one is the 2. So I'm going to have for my highest common factor 2 to the power of 2. Okay, times 3 and 3 squared. The lowest exponent is this one. You can't see it, but remember, if you can't see the exponent, it means it's a 1. So the 1 is smaller than the 2, so it's going to be 3 to the power of 1, or just 3, times, and then over here, they both are the same. So it's just going to be 5 to the power of 1, or 5. Okay, so that, if you look over here, it actually is the same as what we had over there. 2 times 2 is 2 squared, times 3 times 5. So that also gives us 60. Okay, and then to find the highest common factor, we use the lowest exponents of the common factors. Okay, now we're going to take, for the lowest common multiple, the opposite. We're going to take the highest exponents of all the factors. Okay, so over here, the first one I've got is my 2's. Now I'm going to take the highest exponent. So it's going to be 2 to the power of, the higher exponent over here is the 3. So it's going to be 2 to the power of 3 times, over here with the 3's, the highest exponent is 2. So it's going to be 3 to the power of 2 times the 5. They're the same, so it just is going to be 5. Okay. And now we're going to go and multiply that together. But if you look over here, 2 times 2 times 2 is the same as 2 cubed. 3 times 3 is the same as 3 squared, and then times 5. So this is the same as what we had over there, so it is also going to be 360. Okay, so now I'm going to give you a couple that you're going to do for yourself. The first one you're going to do is this one over here. You need to find the highest common factor and the lowest common multiple for the numbers 360 and 324. You can choose if you want to use the first method or the second method, but either way you need to do the ladder to write your numbers as product of their prime factors. Okay, so I'm going to give you 2 minutes to work on this question. Okay, so let's go through that example quickly. So we had the number 360. To do the ladder, you're going to take the number 360 divided by first 2 because it's an even number. So 2 goes into 360 180 times. Then it's still even, so I can still divide by 2. That gives me 90. It's still even, so I divide by 2. That gives me 45. Now I can divide by 3, and that gives me 15. I can divide by 3 again, and that gives me 5. And I can divide by 5, and that gives me 1. So now that is the ladder for 360. The next one, 324. First of all, if I divide by 2, that should have given you 162. Then if I divide by 2 again, it gives you 81. Then if you divide by 3, because it's not even, you can't divide by 2, that's going to give you 27. Divide by 3 again, that gives you 9. Divide by 3 again, that gives you 3. Divide by 3 again, and that gives you 1. So that's what your ladders should have looked like for the two numbers. Now we're going to go and write them as a product of their prime factors. So I'm going to use the second method, but if you chose to and you wanted to use the first method, that's fine. You should still end up with the same result, okay? But I'm going to be using the second method. So the first method, or the first number, sorry, 360 is equal to, there are 3 2's, so that's 2 to the power of 3, multiplied by, there are 2 3's, so it's 3 to the power of 2 multiplied by 5. And then the second number is 324, which is, there are 2 2's, so it's 2 to the power of 2, times 4 3's, so it's 3 to the power of 4. Okay, so now I'm going to go and work out my highest common factor and my lowest common multiple. So remember, for the highest common factor, you're going to be using the lowest exponent. It's the opposite of what it sounds like, okay? So the highest common factor, you're going to be using the lowest exponents and only of the common factors. So over here, 2 is common, so I'm going to be using the lowest exponent. So it's going to be 2 to the power of 2 multiplied by, then 3 is also common, so I'm going to be using it, and I'm using the lowest exponent again, which is 2. So I've got 3 to the power of 2 and 3 to the power of 4. 2 is smaller, so that's 3 to the power of 2. Then 5 is not common because there's no 5 for the 324. So I'm not going to be using it at all when I'm doing the common factors. So 2 squared times 3 squared, that is 4 times 9, which gives you 36. Okay, so that's what you should have got for the highest common factor. Then the lowest common multiple, now you're going to be using all the factors and you're going to be using the highest exponents. So for the 2's, I'm going to be having 2 cubed. Multiplied by, for the 3's, I've got 3 to the power of 4. And then I'm going to be using times 5 because I've got a 5 over here. Okay, and now I'm going to go and work that out. Now you can actually just type this straight in. So you've got 2 cubed times 3 to the power of 4 times 5, and that gives you 3,240. So that's what you should have got for the lowest common multiple for those two numbers. Okay, now you're going to do one more question for today, where you're going to find the highest common factor and the lowest common multiple of 2,880 and 9,000. I'm going to give you 2 minutes for this example as well. Okay, so let's go through that and see what you should have got. So first of all, you have to do the ladder for 2,880 and 9,000. So first, 2,880 is an even number. So I can divide that by 2. That gives me 1,440. Then I can divide by 2 again, and I can get 720. Divide by 2 again, that gives me 360. Divide by 2 again, that gives me 180. Divide by 2 again, that gives me 90. Divide by 2 again, that gives me 45. Now it's not even anymore, so now I'm going to divide by 3. That gives me 15. 3 goes into 15 5 times, and then I'm going to divide by 5, and that gives me 1. So 2,880 is the same as 2, 3, 4, 5, 6, 2. So that's 2 to the power of 6 multiplied by, there are 2 3s, so 3 squared multiplied by 5. So that's what I should have got, or that's what you should have got for 2,880. Then we're going to do the same thing for 9,000. So for 9,000, I'm going to divide by 2. That gives me 4,500. Divide by 2 again, gives you 2,250. Divide by 2 again, that gives you 1,125. Then it's not even, so now we're going to go on to 3. So divide by 3, that gives you 375. Divide by 3 again, and that gives you 125. Now 3 doesn't go into 125, so now we're going to go on to 5. That goes into 125 25 times. 5 goes into there again 5 times. 5 goes in again once. So for 9,000, you should have got 2 to the power of 3 times 3 squared times 5 cubed. Okay, so now we've got our two numbers written as product of their prime factors. Now we're going to go and find out what their highest common factors are, the highest common factor and the lowest common multiple are. Okay, so first, the highest common factor. Remember, to work out the highest common factor, you're going to take the lowest exponent of all the common factors. So we're going to have 2, and then over here, the lowest exponent for 2 is 3. So it's going to be 2 to the power of 3 multiplied by, the 3 squared is the same, so it's just going to be 3 squared, multiplied by, and then 5, this exponent is 1, that is 3, 1 is smallest, it's going to be multiplied by 5. Okay, that, if you work that out, it should give you 360. So that's what you should have got for the highest common factor. Then the lowest common multiple, we're going to take the highest exponent of all the factors. So for the 2's, the highest exponent is 6. Multiplied by, for the 3's, they're the same, so it's 3 to the power of 2. And then multiplied by 5, the higher exponent over here is 3. So it's going to be 5 to the power of 3. So that's going to be 72,000 is what you should have got for that one. And that is the real number system, the properties of numbers, and factors and multiples. Now that we've learned the concepts in this lesson, it's important to practice, practice, practice. If you haven't already got the worksheet that goes with this video, you can find it by clicking on the link in the description below. The worksheet comes with an extra exercise full of questions for you to work on to master the concepts covered in this lesson. If you found this video helpful, please hit the like button so that others can benefit from it too. Also, be sure to subscribe so that you can easily find my other lessons, and hit the bell so that you will get notified about lessons as I upload them.